close out the day today, our final panel on the main stage, bring together 3 very incredible industry-leading AI experts to discuss and debate the current state and future trajectory of AI, industrial AI, and AI agents. David Rogers, who's over there, is our moderator, is Databricks Senior Solutions Architect, who brings a broad understanding of the industrial landscape, particularly manufacturing, transportation, and energy sectors. He'll be joined by Dr. Pattie Maes, Professor of Media Arts and Sciences at MIT Media Labs, who pioneered the concept of software agents in the 90s and has been on the forefront of research on human-computer interaction at MIT. And panelist Ashtad Engineer, who's the worldwide head of auto and manufacturing solutions at AWS. So welcome to the stage, and take it away.
Thank you. So we're gonna start off the panel with grounding our conversation. So to start off, we hear the term AI. It's around us constantly. But we're going to talk a little bit here. We're at an operations calling conference. We're going to talk about industrial AI or operational AI, or Pattie may even take it a little bit more in the enterprise sense. So Ashtad, what does industrial AI specifically mean to you?
I think in its more simplest form, it's the application of AI techniques really to the data generated from OT systems, engineering systems. AI, the use of AI, industrial AI, is really being able to be in a much more controlled, constrained environment. So the predictability and I would say the reasoning aspect of it is an important one, with guardrails and security. So it's really being able to help manufacturing, which is actually physical movement of goods, right from design to manufacturing and supply chain. So it's really being able to have AI, techniques being used on the data generated from physical systems and the systems supporting manufacturing. That's how I would put it. Yeah.
Pattie, anything you would like to add to that as you go through your...
The use of AI in an industrial context, but AI can mean many different things. The word AI. AI is really a catch-all term for any kind of task that ultimately that we used to need people for, and that of course increasingly can be done equally well or better by machines. But that can be many different things. That can be classification and perception, for example, perceiving defective parts on a conveyor belt. That can be modeling and simulation, for example, digital twins of machines, etc., to do simulations of particular processes. It can mean machine learning, like predicting say supply or demand or inventory, etc. It can mean machine learning, learning from historical data. It can even mean agents, systems that can act autonomously to automate business processes.
Yeah, we'll get into agents here shortly, but to follow up on this, Ashtad, could you share a concrete example? I think in your role, you see a lot of AWS customers of where it's moved beyond maybe a pilot project, but it's delivering ongoing real value.
Oh yeah, I mean, I think we are seeing a lot of adoption, especially in things where, like for example, quality, for example. I'll just take vision, computer vision. We're seeing a lot of quality inspection being done by generative AI, really being able to, like for example, I'll just give an example of pizza manufacturing, frozen pizza manufacturing, right? Everybody loves pizza, right? So really CV down at the edge, being able to do counting of pizzas, distribution of spread of the ingredients, so on and so forth. But that could be done by classical, AI in terms of the labeling data sets and image and all that. But I think the next frontier, what we are really seeing out here, is really using that data and connecting to the processes upstream and downstream. And when I say that, it's really using the information for, say, raw material quality consistency, and being able to take actions based on that. So in manufacturing, you've got a concept known as center lining, right? You want to center line your process, and you want to center line your whole line. It really starts, managing it at that level. So we've seen things like that, happening in the field, and of course, certain parts within manufacturing, maintenance, we see a lot of assisted troubleshooting to our maintenance technicians, really being able to create workflows, for example. So AI is really helping them from a productivity perspective right now. So a maintenance requisition, filling of a maintenance requisition, to really planning and then scheduling. That's a huge process, right? And if you can take the burden out of, go mine data from SAP, and just give the operator or the maintenance tech a long, short text, and you can go start doing histories. I think that's a huge improvement, and I think manufacturers are realizing that.
Absolutely. I think as you're describing those different processes that go on in an industrial company, it takes a lot of context for that for the AI or the algorithm to be able to figure out kind of what to do. And really that's where we're going to go next here around AI agents. Autonomous systems are designed to have this context in mind to achieve goals. So for industrial operations, maybe I'll start with you, Pattie. Are these agents a tangible reality? Can the audience here harness them, or are they mostly hype?
So yeah, the word agents really means a system that can operate autonomously and take care of a particular task or goal autonomously. So something as simple as a thermostat is an agent. It senses the environment, and when it's too cold or too warm, it kicks in, basically. Now, that's a simple agent, rule-based agent. Doesn't even have to be digital, but of course they can be digital, and then it gets a little bit more interesting because that agent can maybe learn from experience to predict, say, when it's going to get colder or warmer, and can optimize the use of energy to keep the temperature within a certain acceptable range. Or you could go even more complex, build even more sophisticated agents that talk to other agents, like the Nest may talk to your car about whether you're almost home, so that it knows when to turn on the heat to again minimize energy use. And maybe one day your Nest will actually have an LLM in it and will have all the world's knowledge and will know that, you're on vacation because your calendar says you're in Greece, so it actually shouldn't be optimizing the temperature in your home. That's sort of, we're not at that level, and I wouldn't necessarily want to run an agent like that to control my temperature in my home yet, because of course these large language models are not completely reliable, trustworthy, etc. Yeah.
Absolutely. I mean, in the manufacturing context, right, you want to control the temperature for a process, and you want to do a changeover more intelligently based off the production schedule. So I think that metaphor of the smart home certainly applies in our world. Ashtad, is there any, you think it's still mostly hype, or is there other realities you're seeing?
I would say it's real. In the sense where agents are more advisory right now than actually taking actions. So if I back off a little bit and just, what's an agent? So, it's something which, as Pattie said, you provide sensory inputs, it knows the environment, you give it context, and then it actually takes some action. Today, an agent could be an if-then-else logic. That's just a definition of an agent, heuristics, experience. A AI agent is basically the same thing, but actually using an LLM to reason and take action. An agentic AI would actually be a collection of agents working in orchestration to solve a business problem. So really today, what we're really seeing is fundamental horizontal workflows, data onboarding, for example, very, very simple, data cleaning, data quality, those are being done by agents because those are very structured way where you can, go out to systems, start doing the, creating your data model, so on and so forth. We are really seeing agents from an aspect where you are really talking about a business workflow, and I talked about that from a maintenance perspective. So we are really seeing the application of agents solving workflows, and I think that is a key distinction between just having a chatbot giving you hey, instructions and go do that, or making sense and doing synthesis of the knowledge which is available to do your work, right? Yep. So I think I would be cautiously optimistic. We've not yet reached the level of autonomy, because to reach the level of autonomy, you'd actually have to create digital twins which are nothing but a physical, a replica, and that takes time because you have to know the system state and the system's response dynamic. Yep. Once you figure that out, I think then you start, figuring out your lights out, your autonomous. So I think that layer of digital twin and understanding is very important.
Excellent.
Which I think will happen in another, I would say, going forward.
Yeah, so that goes to a follow-up. So you have this context. I think the way you framed it around there's a response, and the AI is kind of learning what the cause effect is. But what are some of the biggest technical or operational hurdles? Is it the data quality, being able to get the data in a way that you can actually help the model understand cause effect? Is it safety protocols, human trust? We hear about these hallucinations going on. Are any of these kind of the biggest ones you're seeing? I know, Pattie, you've been studying this for a long time, so you probably have a really good kind of perspective of the history. So where are some of the next set of challenges?
I would say all of the above.
Okay.
Yeah. Yes.
Are issues. So especially agents that are based on these large language models. Anthropic, for example, did an experiment themselves. They had a small fridge in the office, and they decided they would build an agentic system that would sell sodas basically to people at Anthropic, and it would decide when to order more soda and which kinds and how much to sell it at, like what to set the price at, etc. It was a complete disaster, basically. It was very non-optimal in deciding when to reorder supplies. It was very non-optimal in setting prices. It was easy to influence it and change its behavior, but then it would forget about that again soon after, and so on. So it was really not a good experiment. So we're definitely not ready for these agents that just take care of it all. So trust is a huge issue, reliability, but also liability. Whose fault is it if you run, say, some agent that relies on Anthropic and it does the wrong thing and it causes $1 million in damage or something? Who's going to be held liable for that? So there's also data privacy is a huge issue. If you have an agent run by a company externally, it might siphon off some of your data, do something with that. We don't know what necessarily, so lots of problems to be solved.
Absolutely, especially when it comes to security and data, right? And I think that's an important aspect because especially in industrial settings, the explainability of what an agent does is so very important. And replayability, I always call it, can you replay that scenario? Can you simulate that scenario? Because today, you have a 30-year-old operator operating the machine, and suddenly he gets something with the advisor saying, hey, go set points. How did you come to that conclusion? So I think that whole explainability part is an important part of agent. If your agentic system can actually work with lights out in terms of if network goes down, where it works, at the edge or at the cloud. So I think there are a lot of these things today which is being figured out, especially. But I would say explainability with security of the data, because at the end of the day, whose IP is it, right? And I think that is where the industry is trying to figure out, is the IP a system integrator coding if-then-else rules or using LLM in the background, or you're actually coding, say, for example, a bioreactor, and you've got, from first principles modeling, you come to know the reactions, you come to know, mass transfer, heat transfer, and you've come to know, energy. How do you model that as in an agent, right? And I think that is where I would say companies are really trying to see where they put their IP. And to Pattie's point, if the agent fails, then who's responsible for it, right? What are the risks and what are the liabilities? So these are things which are right now, we're figuring it out.
Excellent. Yeah. The Anthropic, the vending machine. It's a great blog post. Everyone should definitely read that. It'll really help you reason about the way you want to think about applying AI agents within your business. So, and speaking of which, we're going to kind of go into the business side here quickly. Ashtad, I'll start with you. In the software world, we see a lot of subscription model, software as a service. Is there going to be an agents as a service? Is this something that's going to start to gain traction, or as maybe some of the vendors here are thinking about agents in their products? Is this something that's going to take off, do you think?
I'll give you a different perspective here. I would say the whole software development paradigm is going to change in another 2-3 years. And when I say the whole monolithics of what you see today of Workday, SAP, and so on and so forth, that disintegration of a stack where you have systems of records. So if I say systems of records, it could be your machine, logs, so on and so forth. Then you have the agent ecosystem which sits in the middle. Now that agent ecosystem is an important part because that's what your business rules, logic, so on and so forth. And the third is basically your whole outcome-based persona, the UX, which is there. So I really feel today what we have, and I think it close relates to, we've got MCP, we've got A2A, right? Which have not fully solved the problem. The problem of semantic vocabulary of agents, really understanding what a pump is, or what an invoice is, or what are that layer today is either engineered in a knowledge graph, that layer is engineered either in your prompting, scaffolding, which I say, or it's in the data in your connectors. Mm-hmm. So I think once that happens, I really see agent as a service in outcome-based pricing happening, right? I really see pricing not on a per seat basis, but I really see pricing happening on outcome in terms of, hey, per asset basis, or if you like per lines or so on and so forth. So I really feel we have a little way to go forward because, again, comes back to, am I giving you a framework to develop the agents, or am I giving you something agents which are really 60% there? Quality, energy, which, hey, it's okay, but when it comes to specialized agents, the knowing of the schema, the data, the knowing of the IP, I think it becomes important to drive those outcome-based pricing. And I see that happening, especially with product vendors.
Absolutely. Pattie, I'll kind of throw this one to you. So I learned you were your co-founder here. Yeah. So here at Tulip, but and this kind of goes into like what could a model even look like for monetizing these kind of agents as a service? Is this something that you cover in your research and think about?
Yeah. Well, maybe not so much me personally, but my colleague Ramesh Raskar is very much. Sort of deep into the multi-agent world. And of course, these days, Silicon Valley always needs a new thing to hype and be excited about to bring in even more money for all these, for all these expensive models that they're training and so on, and agents and multiple agents negotiating with one another and so on are sort of the latest vision that they have proposed, but we're really only taking baby steps right now, I would say, and there's still a lot of competing models. For example, there's different protocols proposed by different companies for sort of having agents talk to tools, for having agents talk to other agents, or even discovering other agents that can perform a particular task and maybe seeing what their rating or their reputation is and so on. So all of that is being sort of developed both in academia, actually, as well as in industry. Personally, I like the sort of standards that are open source, that are distributed, where multiple parties are involved in coming up with one of these agent interoperability standards or agent-to-tool standards, so that there isn't sort of one player that has an unfair advantage, basically. Yeah.
I think, we're in this rapid innovation cycle of people figuring this out. So being open helps drive many companies, many academia together to kind of figure this out together. So I think that's something we certainly see on a day-to-day. But Ashtad, back over to you on kind of thinking, how should the audience kind of think about building the agents and these models, maybe the underlying models versus, including them from vendors. And it could be the OpenAIs, the Anthropics of the world, but it could be other players that come up. How should they think about that?
So, and it goes back to what I was also about to add is the small language models, right? The small language models are really not these big foundation models, but really understand the domain. And when I say when it understands the domain, it understands the ontology, like a quality SLM or a scheduling SLM for that industry, right, which really helps them. So I think picking a model from a reasoning perspective is great. And I think you should do model evaluation. But at the end of the day, it's your business process on what is it that you really want the model to do, or you really want the agent call out and the model and the reasoning aspect. And I think that reasoning aspect is very, very tightly coupled with your business process. So it's not that, hey, I'm gonna create a model, I'm gonna do that, and here I am, I'll claim victory. No, it's not that, right? I think understanding of your business is going to be very important, and especially in manufacturing, I would say the correlation of data is going to be very important, because I again come back to semantics of that data, right? I again come back to if the temperature goes here, was it the variation in my dough which had which a little bit of moisture content, because now downstream I have to really inject, or I really need to inject a hydration into the dough. I think those decisions is what the model will be able to take. And that's where, choosing a model based on your criterias are going to be very important. So I think I would not term it that, hey, model A is better than model B. It's how you're going to use the models for your business, and for what use case are you going to use.
Yeah.
Fine-tuning.
Fine-tuning, yes.
With your own data.
With your own data.
Yeah.
Yes, so there's certainly multiple techniques to bring in your domain knowledge into these foundation models, the small language models, whatever kind of appropriate for your equipment. I think that's something to think about as you get into this AI world of what makes sense, what type of model, and that's where companies like AWS
and RAG solve that problem by feeding the foundation models your information. But I think fine-tuning, I would say, really helps when you're getting down into real manufacturing operations, because that's where with your data you can fine-tune a model rather than, or you can use a combination of a hybrid model of a RAG and fine-tune, but then that gives you your competitive advantage on how you are actually using those models for solving a business workflow.
Excellent. All right, so we kind of touched on some of the techniques here. We have one final kind of question here around some standards. We touched on it a little bit, but I think MCP seems to be the one that's captivating everyone's attention. I think there's a lot of demos out in the Experience Center with MCP. Is there going to be a winner-take-all protocol here in this industrial ecosystem, or is it going to be some mix and match? Kind of, what's your take? Start with you, Pattie, on where these protocols or kind of how it may play out over time. If maybe it's MCP, maybe it's something else, but is it going to be one? Is it going to be two? Is it going to be 10, 20? What are your thoughts on that?
Well, I hope that it's one, but that it's one that is a collective type of protocol that some party that doesn't have an interest themselves has coordinated the production of or the creation of. So, but yeah, ideally one rather than many, but totally open, collectively created by all the stakeholders. Yeah.
Excellent. Ashtad, do you have a different take on
I have a different take, and I say no.
Yeah.
Oh, really?
Yeah.
Especially from an industrial perspective, because again, we've seen this movie played out 30 years back with the field bus foundation. You've got Ethernet IP, device IP. I think manufacturing is such an environment where there are legacy 30-year systems, and I think being able to really understand those systems at I would say a middleware level, a protocol translation level. I would really want that happening rather than having one rigid protocol. Because today, again, we move data. You've got protocols like MQTT who could move data, right? I mean, it's there. I think what is really required is if we are able to figure, especially the layer out, which does the translation, does the semantic meaning, and still being able to, because again, this is legacy code, this is legacy machines, so on and so forth. So I feel having a federated approach on being able to, because again, the whole cost of really creating a standard, like, I mean, you've got standards, you've got ISA S95, 88, batch. I mean, these are, OPC, right? These are standards which are there. And that's why I really feel like, okay, MCP was what OPC was to devices years back, right? It gave you, hey, I'll call a tool with MCP, so on and so forth. Great. It gives you guardrails, security. You have an expression coming out, standardized stuff. But again, I come back to meaning, right? At the end of the day, with even from an agent-to-agent communication. And I think that if you leave it up to the standards committee or whoever, I mean, I'm sure there will be different standards committee coming up with this. So I wouldn't rest myself just getting down to one protocol.
Yeah, I think the industrial ecosystem has been, we'll say, a mess in all the different kind of protocols that it takes to operate equipment and orchestrate that. Hopefully AI can streamline some of the communication protocols as they kind of come maybe from more the cloud layer, we'll say, and maybe the industrial providers, it's a little bit easier for them to adopt something that's kind of built rather than build their own. But yeah, I think it's
the adaptability of the AI today, right? And I think that's the reason why in a very heterogeneous environment, which manufacturing is, right? Making sense of, because today if you go back again and look at it just from a data lens perspective, you've got multimodal pipelines today with voice, sound signatures coming out of your stamping press on CNC machines. You've got imagery, you've got logs. So you've got a very multimodal ETL pipelines coming in, each having their own way and connecting and standards mechanism. I think the disintermediation happening at a level where it makes all sense of that data with the semantic vocabulary is where I would see AI really helping.
Yep. I think that's the goal. We'll see if we can get there. But that's all the kind of questions we have here for the panel off the bat. But we're going to open it up to the audience. I think we have a couple mics here. And any hot questions around AI that you're looking to get answered?
We're all figuring it out.
Yeah, if you want to.
Wouldn't you agree?
Sorry?
We are all figuring it out
Yes,
as we
go.
As we go.
Unfortunately.
Suresh from Accenture. I work with many other pharma firms. Ashtad, I really like the call that you made on the explainability of agents.
Yes.
My question is around life sciences manufacturing, which is highly validated, and with building number of agents and things like that. How can we scale with so much of validation and the GMPs in place compared to the automotive industrial?
Yeah.
And what will be our advice or coaching for the life sciences firms?
I think life sciences has the whole 21 CFR part 11, right, where you have to go through a validated. And I think at a state, if agents are actually changing the state of the system or getting the right, then I think validation is a necessary evil for that. I mean, you can't escape that, right? And that's why if you see in the pharmaceutical industries, years back, process analytic techniques where they were really trying to use and speed up quality decisions of manufacturing cycle times with data, right? From that aspect. So I would say when you are really scaling that sort of systems, it's being able to really which type is it a horizontal scaling of the agents which you're doing or the vertical scaling of the agents you're doing? And I think that is where I would say SLMs come into picture, because now SLMs are really modeling and being able to provide the value to your process. And I think those are fewer than the ones which you will build at the horizontal layer, right? Or from a scaling perspective. So I would really, I would really go that way if you ask me.
All right, thanks, Ashtad.
Excellent.
I mean, I know 21 CFR, it's a validated state. And to the whole thing about agent being able to go and interact with the system of record, right? The minute you touch the system of record, it's, the whole validation in the pharma industry. I mean, you have to validate those systems, right?
Any other pressing questions?
But I've seen really in the whole biomechanic reactors, all that, this being really used in understanding a lot of first principle modeling of your equipment and data, where actually happens. It's a science, it's there, right? But I think the agents come in with the more empirical data from, because again, with the machinery wear and tear over years, you might not see the reactor being as built and designed from a yield perspective. And that is where AI, with empirical modeling of real-time data, with your first principles models, which you already have, right, in some shape or form. I think that is where AI's true value is, in being able to, I always say, system state and system dynamics. That's your digital twin. You get that right, you can have any agents on top doing a lot of these things. But I think that's the core of where this whole simulation and lights out manufacturing and all that. And it's hard.
With that, let's give a round of applause.